CFTR VEP exercise. Resequencing of the genomic region of the human CFTR, cystic fibrosis transmembrane conductance regulator, ATP binding cassette, subfamily C, member 7 gene, has revealed the following variants, which are the alleles defined in the forward strand. Use the VEP tool in Ensemble and choose the options to see SIFT and polyphen predictions. Do these variants result in a change in the proteins encoded by any of the Ensemble genes? If so, which genes? Have the variants already been found? To find the answers for our exercise, we're going to select VEP from the blue navigation bar at the top. We're now on the Ensemble Variant Effect Predictor VEP page. This page gives us a little summary of the different things that the VEP can do. And if we scroll down, we also have the different VEP interfaces. We have the VEP interface, the command line tool, and the REST API. We're going to choose VEP interface, and we're going to select Launch VEP. We can now create a job for VEP. Firstly, we will have to choose our species of interest, which in the case of our exercise is humans, so we will leave this as Homo sapiens. If you're looking for VEP for human GRCH37, you would need to go to the GRCH37's website and navigate to VEP from there. Next, we can name our job. I'm going to call it VEP exercise. In the next step, we can input our data in the text box provided. We can either paste our data in this text box, we can upload a file from the computer, or we can provide a file URL. I'm going to paste my data for the 3 variants in this text box. Our data here is in the Ensemble default format. In the first column, we have the chromosome number, which is 7. We then have the variant start position and the variant end position, followed by the alleles. We have the reference allele / the alternative allele. We can also input our data in VCF, variant identifiers, HGVS notation, and SPDY format. Next, we have the option to choose the transcript database and also additional configurations. For this exercise, we're going to leave the configurations as is. And we're going to click on Run at the bottom of the page. The next page shows that our job is in the queue. This page refreshes itself every 10 seconds, so you don't need to refresh it. On the right-hand side, we have the option to save our job, edit it, share it with collaborators, or delete our job. The green button here indicates that our job listed is now done. We're going to click on View Results. We're now on the results page. We have the summary statistics, which shows us the number of variants that we processed, the novel and existing variants, the overlapped genes, overlapped transcripts, and overlapped regulatory features. The pie chart shows us a summary of all the consequences. We can scroll down to view the table with consequences terms from the Sequence Ontology project. In the first column, we have our uploaded variant. We have the location of these variants, the alleles associated, in this case the alternative allele used to calculate the consequence, gene symbol and ensemble stable ID. We have the cDNA position, the relative position of the base pair in the coding sequence, the protein position, the reference and the variant amino acids, codons, existing variants, so we have the identifiers of the existing variants in this column. And if we scroll across the table, we can find SIFT and polyphen scores here. If I scroll down, I can see some polyphen and SIFT scores, and these are available for the variants with the missense consequence, as is shown in the consequence column. The exercise also asked us if the variants have already been found. We can find information about the existing variants by going up to the summary statistics. Over here in the novel/existing variants line, we have 0 novel variants and 3 existing variants. Therefore, all 3 variants have been already described, and we can find their identifiers in the existing variants column in our table below.